Hello to everyone there. Welcome back. So now we're going to learn about homothecy. Homothecies are polygon transformations, but they are not isometries, because the size of the image is different than the size of the original. But before, we need to understand two concepts. The first concept is congruence. Its symbol is like an equal with a set on the top. We say that two figures are congruent when their shape and size are completely equal. So in this case we are looking to triangles ABC, A prime, B prime and C prime. So both triangles are congruent. In this case they have the same sides and the same angles. Another important topic is similarity. It's like a small set, and in order to say that two figures are similar, their shapes has to be equal, regardless any difference in their size. So we have now the triangle ABC and XYZ, so they are similar. They have the same angles, but the distance between the sides are not equal. You can twist the triangles if you want, and then you can realize that they are equal. Okay, it's like a projection, one small and the other one bigger, but they are similar in this case. So in order to understand easily, let's assume that these triangles are similar. So you can see some colors, they represent corresponding sides. If they were in the same position, the colors will be in the same place. So the idea is to put the triangles ABC and XYZ and put it on the base. The base is CB in the small one, and the base in the big one is X and Z. So you can see the difference. Now we have a small triangle and a big one, but they are equal. So they have the same angles, but they don't have the same sides. For example, we have now two squares and two triangles. We can have it separated. These are similar because they have the same figure. Now they are in touch. They continuing similar. You can place the figures in the middle. They are similar. Or you can move the figure, the small one, to the corner. So we use this effect when we are designing. Okay, so it's interesting. You can place the object again to the other corner. So we have the same shapes, but the length is different, and we have here the same angles. Okay, so now we have the corresponding angles of similar figures. In this case they are the same. So the angle in A is equal to D, the angle in B is equal to E, and the angle in F is equal to C. So this is pretty easy to understand and to see when we have the same triangles. So now we are going to look at digital resource, and we are going to explain and to show you another example of similarity. So I'm going to give you the link.
Okay, so now we watch a video. So I want to listen to you. Somebody could explain me. What did you understand?
Yo, teacher, yo.
Okay, Joy.
you want that I explain in Spanish or in
No,
English?
I want in English.
Okay, the video is about the congruents that are two shapes that have a that are similarity, yes,
Yes.
that are different but are similarities.
Okay,
For
well done,
example, the
Joy.
triangles that you put in the video.
Okay, that's great, Joy. It's a good definition. Uh, Vargas.
I speak, teacher, I speak.
Yeah, yeah.
The definition CCC is about the polygons that are congruent and similar. Congruent that the same shape and the same figure. And in similar have the same figure, but the shape, but the is different. Is with a different side, is more big and small.
Okay, well done. Thank you, Vargas. That's really good. Martin Alejandro.
So the video was about homothecies that are polygon transformation, but they aren't isometries.
Isometrics. Yeah, isometric is because iso means equal. Okay, and metric, it's like size. Yeah, that's pretty good. Okay, that's the idea. So we start with homothesis. Now I'm going to show you an example and then I'm going to give you the link. But first, pay attention. In this case, we have in the left area a green triangle. In this side, we have a green triangle, and the idea is to create triangles, congruent triangles, and similar triangles. For example, if I took this point, this blue point, and I move here, we have 1, 2, 3 points here, and then I place this point here, I have the same figure, the same sides, and the same angles. For example, here I'm creating another one. And now this is exactly as the original, as the green one. So in this case we have same sides, same length, same angles. So these are congruent and similar. In this case we have, for example, this one. We're going to create this. Now I have this triangle is similar to the original, but in this case is more bigger than the other one, okay? For example, this one. Okay, so the idea, for example, I'm doing this. This is similar?
No, because of the angle.
Exactly, no. Because look, this line is not proportional. So I have to place this point here and I have to move this point here. Now, this is a similar triangle, okay? But it's like,
Perfect, teacher.
okay? The idea, you can practice, look, I could move this here. Diego, welcome. So I have here this.
Hello, teacher.
Hola, Melo.
Hola, Torre.
So, okay, the idea is you have to practice now. I'm going to give you the link. So now, okay, just copy and paste. So click on the link and practice. So remember, we did in class an example. Cuando estábamos en clase recuerdan que yo les pedí dos escuadras que tenían la misma forma, pero una era más pequeña que la otra, o una era más grande que la otra. Es porque quería llegar a esto. Prácticamente lo que trataba de decirles es que tenemos figuras que son congruentes cuando son exactamente iguales o similar. ¿Ok? Podemos girarlas, podemos hacer una reflexión de ellas como si estuvieran en un espejo. Entonces vamos a practicar un poco más. Bueno, para ello vamos a entender lo siguiente. So we have here the title, that's why we start the class with this. So, homothecy. A homothecy is a transformation that creates a similar figure. Bueno, voy a darles un tiempito para que copien esta definición. Yes, I'm here.
Okay.
Now you can do it.
Homothecy, say this?
Yes.
Homothecy is a transformation that creates a similar figure to an original by projecting its vertices from a single point, tomatic center.
Okay, that's very good. You can say homothecy and vertices. Okay, that's pretty good. Now, Gabriela.
Okay, homothecy. A homothecy is a transformation that creates a similar figure to an original by projecting its vertices from a single point, homothetic center.
Okay, pretty good. That's really good. Okay, last person, because we're going to continue. Santiago, Joy. He asked for first.
DJ. Hola, profe.
Okay, dale.
Profe, estás mostrando la definición, no pasa nada. ¿La leo?
No, go ahead.
Okay. A homothecy is a transformation that creates a similar figure that an original by projecting its vertices from a single point, homothetic center.
Okay, well done, Joy. The word is similar.
Joy.
Similar, okay? Similar figure. Okay, well done. So, for example, we have this figure and it starts with a point here called S. I'm going to show you. This point now. Okay, this point is called S. So you divide the distance between the homothetic center and any point with the distance from the homothetic center to that point, the result is going to be the same in every pair of corresponding vertices. So look, we have the figure A, B, C, D, E. So I'm going to show you here, okay, A, B, C, D, E. But when we are doing the homothecy, now we have A prime, B prime, C prime, D prime, E prime. And the figure is bigger, okay? So that is important to understand this topic. Now we're going to see another example. Okay, now we have this. Bueno, aquí en la parte inferior, cuando les envíe el link, hay como un cuadrito que nos especifica que podemos agrandar esto. Entonces le voy a dar clic. Okay, now. In this figure, we have A to B is 4, B to C is 5, C to A is 6. For the homothecy, in this area we have razón de homothesia en esta linecita verde. So I can move this point to show you this is going up. So it's increasing or decreasing. Is bigger or smaller or is equal. Okay, so you can interact with this, but I want to show you here the angles. So I have the angles here. We have 55 in A, 82 in B, 41 in C. But look what happens if I am increasing. The angles are the same. They don't change, even if the figure is small. Okay, so the idea is you practice with this. You can change the distance. For example, AB 7, enter. Now I have another different triangle. Okay, so now I'm going to share the link for you to practice. Okay, let me do this first. Okay, Guerrero, could you repeat the question, please?
Why the angles never change?
Okay, thank you. It's because when you have a triangle, in this case, it's like if you are projecting the triangle with a candle, a lantern, a light. So we have the same figure in this case. So for example, I have this triangle. Let me help you here. Okay, so when we are moving the triangle, is smaller or is bigger, is because you have this point here, the homothetic center. In other words, cuando tienen este punto acá, el punto O, que llamamos el homothetic center, piensen que ese punto es como sus ojos. Ustedes pueden tener una regla, una escuadra pequeñita, y detrás de ella tienen una muy grande, pero tienen la misma figura. Fíjense que si yo cojo en la vida real las dos reglas, la regla no se va a deformar. Tiene exactamente los mismos ángulos. Entonces no importa si es una regla muy pequeñita o es una regla muy grande, y en este caso las escuadras, mantienen los mismos ángulos. Porque son
Profe, una pregunta.
reflexión de ellos mismos, ¿ok? Okay, so now I'm going to show you another figure. This is a direct homothecy. In this case, k equals 2, so is the double of the original. If I move this, it's small now. K equals 0 is in the point. Okay, it's similar to the other examples. I'm going to send you this link. Okay, so now we have to do an activity. Okay, I'm gonna say this in Spanish because it's better for you. Bueno, chicos, tenemos una actividad. A partir del modelo que tenemos, que en este caso es un triángulo, aquí hay dos botoncitos debajo de ejemplo 3. Voy a ponerlo más grande para que lo vean, listo. Ustedes pueden cambiar ese botón y la figura cambian, miren. Aquí ahora ya tengo un rectángulo. Aquí tengo un trapecio. Puedo obtener un rombo o una figura irregular. Ustedes escogen la que quieran. La idea es que van a hacer lo siguiente. En su cuaderno van a hacer 1, 2, 3, 4, 5 punticos horizontales. 1, 2, 3, 4, 5 punticos verticales. Y van a posicionar la figura que ustedes escogieron. Si escogieron el triángulo, pues ustedes diseñan un triángulo diferente. Por ejemplo, yo voy a diseñar este triángulo. Entonces tengo que hacer en el cuaderno dos figuras que sean congruentes. ¿Cómo lo hago? Entonces aquí voy a dibujarla. Aquí tengo la base tiene 1, 2, 3, 4 punticos. Entonces aquí hago 4 punticos. Y hacia arriba tiene 2. Listo, aquí tengo entonces mi triángulo congruent. Y lo mismo haría entonces acá para generar mis otros dos triángulos. ¿Listos? Entonces me van a hacer, escogen su figura, hacen los dos congruent y los dos similar. ¿Ok? Y luego cuando terminen este ejercicio, bien bonito, con regla, con colores, ustedes tienen cuaderno cuadriculado para que les quede eso súper chévere. Y luego van a intentar dibujar este monacho que está acá. ¿Ok? Así como lo ven, van a intentar dibujarlo. Bueno, ¿listos? Esa es la tarea como tal.